I just have to add, all of this is possible thanks to the amazing team behind the Ryujinx project. And I'm here today on behalf of the Ryujinx project, representing an amazing team of people made up of incredibly talented and smart developers. And I certainly won't and can't pretend that everything we're going to be talking about today was all achieved or discovered by myself. In fact, quite the contrary, I'm a fairly small contributor of the project relative to some of the work done by GDK-chan, who is obviously the lead developer, but also ACK and Thog, who have both been here from pretty much the very beginning. We've got Perry and LEJ, Emma Mouse, Exploiter and Moose Hunter, along with a whole array of more casual contributors to the project. But I guess I've been here pretty much from the very start, and so I think I have a fairly unique perspective to share of in the entire project and its progress through the years.
Hello everyone and welcome to the .NET Core Podcast, a podcast where we reach into the core of the .NET technology stack and, with the help of the .NET community, present you with the information that you need in order to grok the many moving parts of one of the biggest cross-platform multi-application frameworks on the planet. I am your host, Jamie Waffling Taylor. In this episode, I chatted with JD, one of the folks who works on the open source .NET-based Nintendo Switch emulator Ryujinx. Ryujinx, as we'll find out, is written entirely in .NET 5. At the time of recording, the team were starting the migration over from .NET Core. There's a wonderful moment during the conversation where JD blew my mind with talk of Ryujit, that's the just-in-time compiler for .NET. And another part where he mentioned some of the features that we have access to in .NET 5 due to some of the work of the Ryujinx team. So let's sit back, open up a terminal, type in .NET U Podcast, and let the show begin. So first thing I'd like to say, JD/Josh, I don't know which you prefer. I've likely already said it in the intro. We're recording this ahead of the intro record time, so there you go. But thanks for being on the show. It's interesting to talk to folks who are building such amazing systems, I have to say.
No, my pleasure to be here.
It's knowing, so like in my day-to-day work, right, I build stuff with .NET Core that's like web applications and business line applications and all the boring stuff that keeps the world moving. And I've built one or two little games with it, but like building it, like replicating an entire hardware setup in C# and .NET is amazing to me, I think.
Yeah. I mean, I come from the same background as you. I do a lot of ASP.NET and stuff like that for work. But having the ability to sort of have an outlet for that, sort of applying the same stuff that I'm learning throughout the day to something that's more creative and more sort of not your run-of-the-mill thing is definitely a great experience.
Yeah, definitely. So how about would you mind introducing yourself to the listeners a little bit? Tell us a little bit about you. Like you say, you're presumably .NET dev by day and ASP.NET/.NET Core dev by day, I guess, and Ryujinx contributor by night, I guess. So what's the actual...
So I do a lot of .NET stuff during the day. I've done... on and off, professionally and unprofessionally, I've probably been working with .NET for the last 10, 12 years. I picked it up at a very young age. I just happened to come across a book in a store that was like C# for beginners or whatever it was. And I picked it up, and I just read that and I was like, this is for me. So that's sort of my beginnings. And over the time, I've just picked up things here and there. A lot of my stuff obviously wasn't done professionally. It's sort of been hobby projects here and there, and it's all sort of culminated into stumbling across one day this project that was built in C#, something that I knew, and was something that really interested me. I'm really into the low-level sort of tinkering and stuff like that. And so combining those two things, my experience with both of those was something really exciting for me.
Awesome. So how do we... So this is something that Josh and myself have discussed before we hit record, sort of off air, how we actually talk about Ryujinx without touching the slightly spiky side of what it's about. But I was wondering, before we hit that, would you mind telling us a little bit about Ryujinx and perhaps the millions of different ways to pronounce the name and what it is and what it's sort of aiming to do?
Yeah. My personal pronunciation is Ryujinx, so that's probably what I'm going to end up calling it. Officially, it's Ryujinx, but I don't know anyone who actually calls it that. So yeah, Ryujinx. I sort of came into the project about 6 to 8 months after it was started. But it was started by an incredibly talented developer called GDK Chan, who sort of just casually thought, oh, this is a cool new system. I thought I'd try and approach this. And he'd used C# and .NET before. .NET Core was very young at that point in time. I think we were on .NET Core 1 or maybe .NET Core 2 when that started. And so the ability to build something like that cross-platform in .NET and C# was very much a new thing. Previously, you had .NET Framework, and if you wanted to build something like that in C#, you're stuck to Windows unless you want to mess around with the beast that is Mono on Linux. And so I think this is really a novel project in that sense, is that this sort of thing hasn't really been done before, at least to the sort of the level that the Nintendo Switch entails. And so, yeah, over the time, we've been through .NET Core 2.1, 3, 3.1, and now we're up to .NET 5. And over time, we've seen .NET Core evolve. And thankfully, it's evolved very much in the direction that our project's been going. And they've added, in .NET Core 2.1, they added things like intrinsics, which very much leads into doing things that our emulator needs to do at the lower level. And it's been incredibly eye-opening for myself as well to see a project like this come to fruition, because everyone has those precompositions. It's like, no, you can't build an emulator in C#. You can't build anything that needs low-level access. It's not as performant as C or C++. It's not possible. You can't stick to websites. But this project to me is sort of like my in-your-face sort of answers, like it is possible. And so over the time, yeah, we've picked up a couple of developers. There's quite a few core developers now who are working on this around the clock. We all love doing it. We all enjoy doing it. And over time, we started sort of emulating homebrew games and stuff like that. So sort of as a development tool for other developers who are targeting, say, homebrew. They want to build Tic-Tac-Toe or Space Invaders for the Nintendo Switch, or they want to port, say, Doom to the Nintendo Switch. Without having development consoles and access to logging and sort of these tools, Ryujinx has been sort of available to them to debug their application, step through it, to see how it runs sort of on their desktop computer rather than on an actual console, and then take it across to an actual console and run it. And then from there, we've sort of expanded into being able to run commercial games, obviously, which is, as you say, the spiky part of emulation. But yeah, in the last 2.5 years that the project's been going, we've gone from no commercial games running to one commercial game running to now over almost 2,000 games being in a bootable or a playable state in the emulator, which I think for an emulator of any sort of level, whether it's a C emulator or a C# emulator or anything, the speed at which this emulator has developed over the years is pretty much unprecedented. And so that's where it leaves us today, with quite a capable emulator, capable of near perfect emulation of a number of sort of top level sort of first party games for the Nintendo Switch. Yeah.
So that's really interesting to me, because like my background, I went to university and did games dev, and we did everything in .NET. And I mean, this was 2002 to 2004, and the lecturer was like, "Yeah, you'll never get like near native performance out of .NET." And I so wish I could track that lecturer down and just say, "Hey, in your face."
Not only are we running a game, but we're actually emulating a game from another console in C# on a desktop machine.
But then I suppose that goes hand in hand with the increases in performance that's brought about by Microsoft and the .NET contributors, and I guess the sheer horsepower that we now have. Because like if you look back at 2002, I think I had I'd custom built a triple core machine that was running on an AMD something or other. and it likely had an ATI graphics card because I'd heard that they were good together. But we're talking maybe 2 gigabytes of RAM, and that was enough because it was Windows 7. No, not even Windows 7, Windows XP. So it's like, this'll do. And it ran everything I needed to run and ran the games as well. But I guess because we've just the orders of magnitude of hardware, and I suppose the compilers and tool chains and the frameworks have just gotten better and better because, you know, people come along and go, hey, can we do SIMD? And like you said, can we do intrinsics? Because why not?
Yeah, for sure. I mean, I definitely think that's part of it, but we're getting to a position where now scaling hardware vertically is starting to hit the limits of what we can do today. So it's like, you have a Nintendo Switch that you want to emulate, but you can't just throw a 15 gigahertz 48 core CPU at the problem. You have to start getting smart about how you apply the technology that you've got. And that's the constant challenge for us. I mean, at the moment, yes, definitely our emulator runs best on high-end CPUs. And one of our big challenges now is, okay, we've got something working. We've got it working on your 5.2 gigahertz 10 core Intel processors, but how do we adapt that and how do we optimize that to bring it down to something that the more average Joe's going to have? Might be a quad core laptop CPU that's only 4 gigahertz. And bringing that performance out is something very, not very easy to do, but it's certainly accessible to C and C++ and native languages. But doing that with a C sharp and a managed language is something that's always a continuing challenge, because not only are you optimizing your code, but you're also having to optimize your platform's code and Microsoft's code and seeing places where things could be better and reporting that back to them.
Sure. There's a, how do I put it? It's always best to sort of, build what you can now. It's almost like, I don't want to end up using buzzwords, but it's like the agile-ish way of doing it. Like, build what you can and then make it better later. Add the scope. Like, if the scope or the features are, can we optimize and make it run on slightly cheaper hardware? You don't do that up front. You know, I think it was Donald Knuth who said, the root of all evil is premature, optimization, right? And so you don't want to be optimizing before you've got something running, because you don't know whether the code actually does what you want it to yet. Optimize it later, right? If
you don't know what to optimize, it's like you're just guessing, exactly. Really. Yep. Oh, I think that code looks slow. Yep,
exactly. So just to retouch on something just real quick, right? Because I don't think we covered it a little bit, but just for completeness' sake, I'm seeing, as an outsider, Ryujinx as a sort of, it's not a, hey, go pirate your games and run them on your computer. It's more a case of, can we do it? Is that the case? Or is it more a case of, hey, go pirate the games?
Oh, definitely not. I mean, I can speak for myself, and I know the other core developers of this project well enough to speak for them on this behalf. We're very much for the challenge. And because we think we can do it, so let's go try and do it. Ryujinx started off as an experimental project to see if we could emulate hardware like this. Whether it may not have even been the Switch, it may have just been, can we emulate an ARM CPU using C# and .NET? And it's evolved out of that. And I think a lot of our developers on our core team have come from sort of emulation and from the sort of the hardware side of it rather than the software side of it. So they've brought a lot of experience with reverse engineering the kernels and stuff like that of these platforms. And it's very much for the research side of things. It's like there's a challenge there, and we see it, and we want to know more about this, and we want to learn about this. And the best way to learn is to do. And so I have this coding skills, and I have this console that doesn't have an emulator for it. How can I put the two together to not only create something? Because at the end of the day, for me at least, I find it very hard to work on something that's not going to produce something at the end that's useful to someone. And so I think having the emulator sort of as an outlet to be like, let's work towards emulating this. It just so happens that a side effect of that is it's a commercial emulator that can emulate commercial games. But even if it couldn't, I think we would still be working on it. And I think we would still be working towards this emulator being a great replica of the actual physical console, just because it interests us and it continues to challenge us in ways that we don't necessarily get from building ASP.NET websites on our day jobs.
Yeah, there's an argument for sort of stretching out and figuring out other things, right? There's a lot of the developers I speak to on a daily basis, either through the podcast or just through like speaking to people on Slack and Twitter and stuff. There's a lot of sort of creative energy in development. Not everyone is full of creative energy. Some people are just like, hey, I'm going to do my 9 to 5. I'm going to go home and be me outside of work. And that's totally fine too. Whichever, if you're super creative outside of work, if you're not creative outside of work, if you are somewhere in between, it's you be you, right? But I've seen that there's a lot of creative outpouring from developers outside of their day-to-day work, where it's like, one of my friends, Joe, he was doing some live streaming of some Python stuff, and I love to watch other people code because I'm like, I want to learn how you're doing it. And I'm sat there going, hey, could you do it this way? Could you fix that? How would you, and it's like being that sort of creative workforce. And he was building a game, and I was like, oh, this is amazing. I've got to tune into this because it sort of lights up that part of my brain that wants to be creative. I'm not terribly musical, but I try, right? And I know a lot of developers who are musical, but like the point I'm trying and failing to get at is that outside of work, we all need that. If you have that creative flow, as I guess, we all need that output, that way to get that out of your system. And if making it, because like what you're doing is you're solving a problem, right? We got a bunch of these chips arranged on some PCBs that we can't read, but we want to recreate it in the computer. Can we do that with something that, like I said earlier on, that in 2002, you're never going to get system performance that you would out of C? Well, guess what? There's this, I've literally got my switch here. I mean, no one can see the video, but I've literally got my switch here just off screen, off camera. Can I make that run on my computer? And why not, right?
Yeah, sure. I mean, I was lucky enough to find the project happened to be in C#. I remember there's actually another Nintendo Switch emulator out there that's called Yuzu that's written in C and C++, and that was the emulator that I initially stumbled upon because I was curious about this console, and then to discover that there was Ryujinx written in C#, this language that I'd been spending the last 12 years of my life indulged in, was just amazing to me. That like the fact that even back then, like when it was running basically no commercial games, the fact that someone was even attempting it, and someone who had similar aspirations to me and who's willing to try these sort of ridiculous things, really attracted me to the project.
Yeah. And like you say, being able to use the knowledge that you're gaining and practicing on a daily basis and sort of applying that, or indeed doing it the other way around. Hey, I've got this personal project I work on in the evenings. We've just figured out how to use this particular feature because, I mean, we were saying just off air, right? That the list of C#9/.NET 5 features is huge. And, you know, a lot of the developers I speak to had been saying to me, well, where am I going to use this? Where am I going to use that? And it's a case of don't look for how you're going to use it. Use it if you need to. You know, you're not duty bound to use records or to use what's that thing with the switch statements where you can just like inline and is
pattern matching.
That's it, yeah, pattern matching and stuff like that. You don't have to do that. It's there if you need it. But then I guess if you or someone else on the Ryujinx team have gone, hey, you know, we've used async IEnumerable. Just check it out. And then you can see a real world application of that and go, actually, I could use this tomorrow when I'm at work. Use this in this situation, right? It's like, because obviously the documentation can only cover like, here is the rationale behind why we built it. And here's like a trivial example. Here's, you know, some data coming in and here we are for reaching over it and yielding that and yay, go do it. But unless you can actually see a real world application of it, which, you know, I'm not trying to say that Ryujinx uses async enumerable or anything like that, but, you know, being able to see those real world applications is so much better than just reading the documentation.
Yeah, and I mean, we've been in the unique position where we've reported things like, hey, Microsoft, we need a way to do this. Or we've discovered a performance issue. We were talking off air about one of the issues is that the suppress init locals, which sounds very technical, but basically when you enter a function, the .NET runtime will zero out basically the entire stack for all the variables that are allocated or declared inside that function. But when you already know you're going to write to all of them, or you're not going to read from all of them, then spending all the time to omit the code and execute the code to zero it all over is pointless. And this has become more and more of a sort of a point of optimization, especially now that we have spans and that we can do a lot of sort of very verbose, memory-heavy operations in C# safely that we never used to be able to do before. So it wasn't really an issue. But we've discovered in lots of places where the JIT is just emitting code that's wasting time to zero all this memory in a function that might be called 1,000,000 times every second or 1,000 times every frame. And we know that we don't need that code. And so we asked Microsoft for a way to solve this problem, and they gave us suppress init locals as an attribute. And this is one of the rare situations where rather than going to find a use case for a specific feature that they've added in C# 8 or C# 9, it's one of the ones where we've been like, okay, Microsoft, when is this going out? Which language feature is it going to be? And we upgraded to .NET 5 as soon as it became publicly available, just because we've been waiting for these features that Microsoft have said they fixed it 6 months ago, or they implemented this feature 6 months ago, and we've been able to put it in place with a practical application before we even knew that it was becoming available in C# 9. So yeah, we definitely, when you start delving into the depths of hardware emulation in C#, you start really relying on all of those new features that a lot of people go, oh mate, I hate records. Records is so silly. It's so verbose. Why can't you just write it with a little bit of extra code? But it's like, you don't have to use it. It's just there if you need it. And there's a lot of features that we make use of now out of C# 8 and C# 9 that a lot of other people probably go, what's the point in that? But we make use of it. And it's one of the crucial parts of making the emulator not only functional, but performant.
Sure. We'll come back to those points in a moment, but I just thought about, what we're talking about here. We are talking about a Switch emulator, but the same could be said for any other commercial platform, or indeed for Chip 8, which I believe is one of those fictional systems that doesn't exist. You can write an emulator for that people have already they've sort of, like in theory proved that this could work as a real system, and they've just put the specifications out there for you, and people write real games for it. So it's like, yes, we're talking about the Nintendo Switch, but this could be Chip 8, or it could be, oh my goodness, what was there's something that Knuth wrote about in his book, The Art of Computer Programming. He comes up with a completely virtual machine and talks through how the entire architecture works, because all of his examples are written in a programming language for this machine that doesn't exist, so that he didn't upset anyone for writing it in C or in Fortran or whatever. Like, he invented an entire programming language and an entire fake computer
to run it,
to be able to write all of his examples for. And he actually, I don't think he does it now, but he used to offer bounties for, if you find a bug in my implementation.
Yeah.
So like, what I'm trying to get at is the scope here is for creating emulators for practically anything, a real system, a fake system, a pretend system like Donald Knuth's, Chip 8, whatever, right? It all sort of fits.
Yeah. The technologies that we use and sort of the fundamental ways that you approach emulating a hardware platform, or even a virtual hardware platform that doesn't exist, are all very similar, and you're going to be solving the same problems. And it's nice to see Microsoft embracing some of the things that we've had, and it's nice to see C# and the .NET Core runtime evolving in a way that further continuously enables people to build more of these exotic solutions to problems.
Sure. So you said earlier on, right, that the entire time that this project has been alive that you've known about, it's been built in .NET, or specifically .NET Core, right? Now I'm going to ask a question, and I don't want it to come across as as sort of like forced, like a, hey, what the heck? But like, why? I mean, other than, can it be done, right? Because I remember at one of my previous employment gigs, they were like, yeah, we're moving everything from .NET Framework to .NET Core. And I just stuck my hand up and went, why? It's all working, right? But then in this instance, if there's already one in C++ and C, technically you may not have been able to contribute as much as you have for this one. But like, why .NET? Is it just because it's now cross-platform? Is it like is there an answer to this? Do you know? I mean, obviously, hopefully you've had a chat with the team before answering this question.
So the founder of the project, if you will, GDK Chan, I spoke to him about this, and very much the reason and behind this is that he had experience with C# and .NET before. He was comfortable writing the code. He was experienced and he was fluent in it. And so not only does it prove a challenge that this has never been done before in C#, but also he can reuse a lot of his knowledge that he already has rather than trying to attempt it in a different language that he may not be as fluent with. So I think there wasn't any sort of underlying ulterior motive to use .NET. It's sort of just been like, well, I know C#, I know .NET. Let's see if this is even possible. And I mean, at the time, I believe the other Nintendo Switch emulator, Yuzu, wasn't public knowledge that they were working on that. So very much so, Ryujinx, I believe, was the first sort of Switch emulator on the market, and then Yuzu came along later. So in terms of sort of like contributing to an existing project, and I'm always of the belief that competition, if you will, is healthy. Both teams have an amazing development team behind each one, and we both thrive off of the discoveries and the learnings of each other. A lot of the code that Yuzu's implemented has been from discoveries of bugs that we've discovered on our end, and they just happen to have the same bug and we both fix it, and vice versa. Some of their team members like Rodrigo, who's their lead GPU developer over there, is constantly working with our team, pointing out sort of issues and stuff like that he's found in his code that we also have. And so I think there's a benefit to having more than one emulator as well, to sort of touch on that point. We've definitely seen a benefit of having two, and it always keeps you motivated when the other guy's booting a game that you're not booting, or you're booting a game that they're not booting, and it's sort of like, oh no, now we need to get that game booting, or they've got some feature that we don't have. It's always fun and exciting, and it keeps everything motivated. But yeah, to come back to the point, I don't think there was a really underlying reason to pick .NET apart from that was what GDK Chan was comfortable with, and all of our team members were comfortable with.
Cool. I mean, that makes perfect sense, right? You pick the tool that you are most productive in. There's a constant argument of which tool will make me the most productive. And I'm like, well, if you're really good at using Notepad, then Notepad. If you're really good at using Microsoft Word, then Microsoft Word. If you're really good at using Notion or G Drive or whatever, it's whatever it is that you're really productive with. Like, technically, you can use a screwdriver to put a nail into a wall, but you're never going to be as productive as using a hammer to put a nail into a wall. If you're using the screwdriver, there's an argument there for you can, but this is the best way, the most accepted way, the way that you are going to be better at. And so I'm always for when somebody comes to me and says, hey, we want you to build this project and we want you to use these technologies, the first thing I always ask is, why those specific technologies, right? Because it could be that you want .NET because .NET is one of the new hotnesses right now. Or you might decide, hey, we want to build it in .NET, but we want to do loads of really low-level machine learning stuff. And whilst .NET does have the machine learning libraries, it might be that Python's better. Or it might be that R is better. It depends on the type of data that you're working with.
It's always the right tool for the job sort of thing.
Yeah, absolutely.
And I think .NET, one of my gripes with it over the years is that people have this preconception that .NET isn't, you can't use it for these serious sort of workloads. And one of my goals with working on this project is to sort of show that you can. .NET, yes, it has overhead, but over the last 2 years since .NET Core's been around, the overhead is continuously shrinking. And the benefit that we have with working on .NET is that not only do we reap the benefits of our continuous improvement on our code, but every single time we bump the .NET Core version up, we get the hundreds of thousands of hours that Microsoft developers have invested in the .NET Core runtime that we can reap. Just recently, the .NET 5 upgrade, there's a whole bunch. There's a performance. They put out like a performance improvement document that sort of details the differences between .NET Core 3.1 and .NET 5. And a lot of the points in there are specific things that we have noticed as being sort of performance hotspots in our code. And the improvements just from upgrading from 3.1 to 5.0 in some instances like a 10, 20, 30, 100 times performance improvement in some of these things. And That's a benefit that we get zero cost for us. We just change a version variable in our build script and boom, now we're building on .NET 5 and we've just gained all this additional performance. And so I think there's a real good reason to build something like this in .NET, versus say C or C++ and other stuff like this, where there's almost two teams working on Ryujinx right now. There's the Microsoft team building the .NET Core runtime, and then there's us optimizing our application on top of that. And I think that's a really unique situation that not many other the languages can sort of, or platforms can sort of claim to have. I mean, you've got Java and stuff like that, which are a lot more mature and sort of foot in the market, but .NET Core is moving at a very rapid pace at the moment. And the performance improvements that we've already seen in the .NET 6 sort of beta, they're not even beta builds, but whatever, the nightly releases, there's already great features that they're working on, and bringing up. And I think that's really exciting when you're working on a project and you can sort of just overnight win additional performance by upgrading your platform.
Yeah, and that feels like it's, like you say, it's a mutually beneficial, not just between you folks working on Ryujinx and Microsoft, but obviously for everyone else, right? Every time you push out a build, regardless of whether there's telemetry involved or not, you get a bunch of information as to whether this is actually better or worse. And then you can take that to Microsoft and go, hey, we've got a user base who are doing things that are performance related. It is important. It is imperative that we get the best performance we can out of our code. And so we're optimizing it. But also we've noticed, like you said, hey, there's all this code that's being executed that isn't actually useful in our use case. So is there like you said, with the zeroing out, stuff when you come into a function, it's like, well, can we disable that? Oh yeah, sure, you can do it. Oh, brilliant. And then anyone else who uses that gets the benefit of that. Like if I decided, hey, I'm going to write some software that needs to do the exact same thing. So like, I don't need to zero out my variables going into a function because I'm going to be using them straight away. And I require them to be set to garbage values and I'm going to reset them anyway. Well, I can use that myself. I don't have to be writing an emulator. I don't have to be trying to emulate a system, real or not, to be able to actually do that. I may need to do that in some of my services, my business line app services. I may need to do that before I can touch my domain models. Everyone gets that benefit.
And that's exactly right. And one of the things that I've found myself doing in my day-to-day job now is that I learn about these sort of performance things. And there is very much premature optimization, but when you're aware of how the JIT works and how the .NET Core runtime works and how it thinks internally, it creates a different way to write code. When you're writing code and you're understanding how it's being executed, something just clicks in your head and you start writing code that may not be how you would typically write code, but you write code in a way that you know is going to be well executed or well optimized, or these little tricks that you'd never have used. Like I would never have researched skip zero init the locals for something that I was doing at work. But now I can see all these potential use cases and just even going back over and reviewing code that I've written for work, where I can apply that and be like, oh, bam, there's an instant 5% performance win on that because I've been contributing to this open source project. And I think, like you say, having a practical application for some of these features that where you can point to it and go like, this is where it's useful, this is where you can use it, is great. And I love to think that some of these C# developers that we see coming through our development channels and wanting to get involved are able to sort of see these things and take them away back to their jobs and grow the collective knowledge about these features and how they can use them in their day-to-day jobs, not just in some super niche market where you're building a Nintendo Switch emulator.
Yeah, it all makes sense. And it's all about that continuous professional development. That's the sort of the buzzword project managery type way of and management way of thinking about it. But yeah, just sort of looking around, back when I was coming out of uni, I was asking people, hey, how do I get better as a programmer? And they went, go read source code. And I was like, really? Can I not just take a course, read a book or, whatever? And they're like, no, go read source code. And it still sits well today.
Yeah.
Go read and write source code and you will get better at it. And like you say, implementing these features, using these framework features. I try not to use the word framework when I'm talking about .NET, because .NET framework is a thing, right? But using the platform features in some kind of outside of work, I'm playing around with something to see what I can build, will always, like you said, it always infers with you, hey, I can use this in real life. I can go back to my clients, my work, my customers, my whoever, right? And say, right, I can actually make this code better by changing one line, right? Or maybe you don't even tell them, and then they just go, hey, we've noticed somehow that we're getting 5 million extra requests going through the system. What have you done? Have you made it better? What's happened? Have you just dialed it up and vertically, horizontally, whichever way scaled? Have you done that? And you just go, no, I'm just that good of a developer.
Yeah, that's exactly right. Yeah. Take some credit for yourself.
Exactly. But like you say, it's part of it. Part of it is having that knowledge and that experience. I keep coming back to IAsync enumerable because I'm still trying to figure out how to use it in real life, right?
Yeah.
But zero init, right? If you don't know that exists, like, how are you going to document that? If you're Microsoft and you're trying to document that for everyone to use, how are you going to document that? Suppose you have a method where you want to not zero everything out on the way in. Like, I can't think of a way that you could document that in a generic enough way so that anyone reading it can go, oh yeah, I'll just throw that in, without obviously mentioning the pitfalls of, but if you do require everything to be zeroed out, don't add it. Like, the only way to learn that is through experience, right?
Yeah. Yeah, and I like to think that from my experience in learning in this, I'm able to sort of instill that in my colleagues as well. Be like, hey, I saw you wrote that code the other day. You can actually do it this way now with this new feature. And now they take that away and they teach their colleagues about the feature. And we all collectively improve the code that we're writing thanks to just things that I've learned in my free time contributing to Ryujinx.
Mm-hmm. Excellent. I agree completely. So we talked about why .NET, and we've touched on a couple of the C#9 and .NET features that you're using, that you have a real world application for. If you have any others, do please shout out. But I was wondering, because we talked about the performance as well, but are there any other unexpected features that you knew, or unexpected advantages or benefits, or even disadvantages of using .NET to try and build up Ryujinx as a system? Is there anything that you know of where you or someone on the dev team have gone, actually, that's really cool. It did that for me automatically. I don't have to worry about that, right?
Yeah, I mean, I think one of the biggest highlights for this one is sort of the initial approach that was used for building the emulator. And one of the unique approaches to it was, so obviously in a Nintendo Switch emulator, you need to emulate the CPU and the GPU. And the CPU in the Nintendo Switch, in this instance, is an ARM-based CPU. And so we can't natively execute that on your x86 CPU in your desktop computer because they're just not the same architecture. This is the same problem Apple actually has right now with their new M1-based Macintosh computers, is that they can't just natively execute all their existing applications because it's not the same architecture. So they've actually built basically the same thing we have, just the other way around, x86 to ARM conversion. And our initial approach to this was actually something that I'm not aware anyone's really done before, is that rather than converting the ARM code directly to x86 and then executing it, what we did was we converted it from ARM code to MSIL, or the Microsoft, or CIL, I believe is what the name is these days. So we actually converted it to C#'s intermediate language, or .NET's intermediate language, which then allowed us to utilize .NET's JIT to actually do the code JIT for us. So we didn't have to build an assembler and code generation and all this stuff. All we did was we used reflection emit. We'd taken an ARM opcode. We emit some Microsoft intermediate language, hand it off to a compiler, and then let Microsoft's JIT do all the work, or Ryujit in this instance, which is actually where the name Ryujinx comes from. And so that was a really novel approach that allowed us to very quickly prototype the entire emulator, because we didn't have to worry about building this big complex JIT or code compiler, all this sort of stuff. Microsoft already had it for us. And it had the unique sort of benefits that, well, any target that Microsoft adds to .NET Core, whether it be ARM, MIPS, x86, whatever, that's all their work. We can just, our code's retargetable now because we can use it cross-platform completely. We don't have to rewrite our code. And this was really, really cool. And for the first year of Ryujinx being around, the first commercial game boots, this is how we ran our CPU code. We converted it to MSIL or CIL and compiled it through Microsoft's .NET runtime compiler. And that was sort of an unexpected but really cool benefit of having .NET. You have this runtime JIT that a lot of other people will go, oh, you want AOT, you want ahead of time compilation, you don't want to have to mess with a JIT and garbage collection and all this stuff. Whereas in this instance, it actually helped us rapidly prototype the emulator into what it could be. Now, eventually we ended up ditching that approach and we now do native code generation because multiple reasons. The .NET JIT's not designed to be incredibly fast for code compilation. So we do, if you can imagine a standard application might have 1 million functions in it in your binary. Compiling all of those at game boot takes an incredibly long time, especially in the .NET JIT. It's getting better over time, but there were just a lot of inherent limitations and performance gains that when you don't have your own JIT, all of a sudden you're reliant on Microsoft to improve these issues, and our use case not necessarily aligns with everyone else's use case. And so getting a lot of these performance things tweaked for us and pretty much us alone, because as far as I'm aware, no one else is doing this, was going to be next to impossible. And so we eventually, I mean, the code's still available if anyone wants to go check out our Git repository. It's all up there. It works. It's pretty cool. But we ended up ditching that idea. But that to me was really cool. And I think that was one of the sort of unexpected, as you say, advantages of using .NET. It also has a whole bunch of other benefits, is that because we're effectively generating C# code, we're able to natively interop with everything else. All of our other C# code just sort of works. We don't have to worry about marshalling to native code and back again, the performance stuff that incurs. And so we were able to get basically get out of jail free card, really, for the first year of development by using this. And it helped us rapidly sort of develop the emulator.
Rolling. Action in 3, 2, 1.
No one calls me these days. Oh, hey, what ho, Squitch?
Have you finished that big new feature for the website yet?
Absolutely.
Hang on. Oh, that's not bad. It loads pretty quickly. There's every episode on it as well.
X.
What's this button all about?
Don't push that button.
That ain't gonna happen.
No!
Nothing happened.
That's what you think. Waffling Taylors is a podcast all about video games and nonsense. Check us out on Apple Podcasts, Google Podcasts, wherever you find your podcasts, or head over to wafflingtaylors.rocks. So if you want to hear more from my brother, who may or may not be a cartoon wolf, and myself about video games and silliness, head over to wafflingtaylors.rocks, or look for us wherever you listen to audio.
And don't forget that we have tons of guests and that we've covered over 1,300 games on our show so far.
And that we have over 110 episodes to choose from, too.
Wafflingtaylors.rocks.
Cut. Print.
Was that okay, Russell?
It was sufficient. Editing now.
I have to say, that is quite possibly the smartest solution to any problem I have ever heard. Like, it already has a JIT, and it will already compile down to native code. So why don't we just use that instead? Just to get started?
What's already available.
That is quite possibly the smartest answer I have ever heard. Like, that is a proper engineering technique. That's like, hey, why write our own for the first version? Let's just get everything working first. That is absolute, and I don't use this term very often, but that is genius. I love that.
It works. I'll put it. It works surprisingly well. When you say I'm converting a native code execution from ARM to Microsoft Intermediate language, and I'm going to execute it in .NET JIT, you go, I don't know how this is going to turn out, but. Yeah, I mean, it just goes to show the performance improvements that .NET has made over the years. .NET Framework, it would have been basically impossible on their old JIT prior to the .NET Core JIT. I just wouldn't have even attempted it. But big kudos to Microsoft if you're listening to this. The team and the work that you've put into the .NET Core JIT is absolutely amazing, and it's definitely made basically the simulator possible.
I'm genuinely blown away by that solution. Because, like you say, it may have been temporary and there may be better ways to do it now. But again, like you say, it then theoretically, you could take this code and run it on any CPU architecture. It may not run performantly, but it would run. right? Somebody invents a new CPU architecture tomorrow, and then Microsoft will alter their JIT compiler to target that. And then you just go, right, build, run, done.
Exactly right. And I mean, we're already looking at this for us to target the new Macs that Apple have just brought out. We're now going to have to introduce an ARM backend for our JIT, which is already underway. We're already looking into it, not necessarily just to target Mac, but also it would be required for like an Android target and stuff like this. But Microsoft are also working to bring up their own ARM-based JIT support for .NET 6 on Apple's new M1 Macs. And so if we had still been using that approach, we would be benefiting from all of that development. Basically, Microsoft paying developers to work for us.
Yeah.
It's very, very, very cool. I agree.
Wow. It is. That's awesome. Because that technique, like I said earlier on, like you hinted at, it may not be performant, but it blows open the doors for, well, guess what? I'm going to write an emulator for X, and it may not be a real machine, it may be a fake machine, but it runs a completely separate CPU architecture, and I will just use the JIT to do the hard work for me. That's just, that's like you've got a free translator.
Yeah.
Right? Why not?
And I think if you were targeting anything outside of the Nintendo Switch, which is a fairly beefy CPU, like your quad-core 2 gigahertz ARM CPU cores, if you're like, say, emulating a Nintendo DS or like a SNES or an NES system, I think it would be entirely feasible to use that approach to emulate their CPUs, perhaps even emulate their GPUs using just a reflection emit and running Microsoft intermediate language through their JIT and executing. I think that would be completely feasible, and definitely something it's on my books to the long list of things that are the cool things that you want to try that gets perpetually longer and never decreases in size. It's definitely up there, and I think a lot of other projects could definitely, if you're out there and you're looking at writing a Nintendo DS emulator or even a Chip 8 emulator, as you say, it's definitely something that not many people probably have put two and two together, but it's possible. We've proven that it is. And if you want to look at how we did it, go check out our Git repository on GitHub.
That's wow. That is amazing. Wow. I'm genuinely blown away by that. So one of the biggest things that stops people from writing things with .NET Core or .NET 5/6/7/8 at the moment is sort of cross-plat the user interface stuff.
Yeah.
Like there's lots of work happening. There's an Electron.NET, which I would personally I wouldn't use because it relies on opening a port to the world. But I mean, that was an early version of it. There's Steve Sanderson is working on like Web UI kit inside of .NET. There's Maui, which is coming out. Or rather, I think I should say Maui.NET because Maui already existed. There's some controversy there.
It's very complicated.
Yeah, there's like Xamarin and all of kind of things that are almost like for all first-ish party solutions. But I know that you all went with GTK Sharp. Now I wasn't aware, or at least when we were arranging this conversation, I don't know whether it's changed since then, but I wasn't aware that GTK Sharp handled could work with .NET Core. So that's really quite useful. I don't know whether that's still the same thing there, but like, was there a decision that went into that other than just like, hey, we need a window manager and we need to be able to make a GUI because an emulator without a GUI, it's kind of useless.
I'm pretty sure like this is a big contentious thing for us at the moment. GTK Sharp, for all its great things, there's a lot of negative things for us as well. A lot of the things that we try to do and try to wring out of it makes life difficult for us at the moment. So, but yeah, GTK Sharp, I mean, I guess it's, as you say, we needed a window manager. We needed something that was cross-platform inherently. And this is probably the biggest place that .NET Core and the .NET Core ecosystem and the cross-platformness can improve or needs to improve, really, is this. There is no universal cross-platform user interface. You've got the likes of Avalonia, which is sort of trying to branch all these things together, reusing XAML and other stuff like that. But there really isn't a solution at the moment apart from sort of binding to these other native libraries. And I guess GTK Sharp was the lesser of evils, if I put it that way. So I guess someone on our team was fluent with GTK. They'd built a GTK application before, and so they sort of just went and built it, and that's what we're stuck with today. we're definitely looking to migrate away from GTK Sharp. So I'm not necessarily endorsing going for that. It's great for simple applications, but for us where we need low level access to certain stuff, it can become a bit of a pain point. But no, it was available, and yeah, like you said, GTK Sharp, I think it targets .NET Standard, so it's sort of .NET Framework, .NET Core, Mono, sort of all that intermingling stuff that no longer exists apparently. But yeah, so we stuck with that. It's worked fine for us for the last year, and yeah, if anyone else is looking for cross-platform, you've got plenty of options, just none very mature.
I mean, that makes sense, right? It goes back to that conversation we had about productivity, right? If someone on the team is really productive with GTK Sharp and they want to build the GUI, here's all the stuff, go do the thing. Totally, right? If you're going to be able to build it in a couple of weeks, couple of months, couple of days, I don't know how long it took the team to build the GUI and be able to actually draw on screen, and that's greatly reducing the actual task. But if it takes a certain amount of time and someone says, I could do it in a little bit quicker if we change to this library for this version, you get it up and running, and then like maybe build that around an interface or something, segregate that out, and then you can just swap it out, right?
Yeah.
Why not?
And I'm very much of the belief that build something for this day. The great thing about code is that nothing is set in stone. If we decide to go down GTK Sharp, as we have, and we decide that, hey, it doesn't exactly work that great for our specific use case, then we can just go and swap it out for something in the future when we have the need or the want to do that. And I feel like a lot of developers get stuck in this cycle of, I need the perfect solution right up front. I have to think about it for months, come up, architect it, carefully build it, document all my code right from the very start to have the perfect solution at the end. But you're never going to have the perfect solution at the end. You're always going to want more. And I think just getting in there, building it, as you say, minimum viable product, getting something out there that was a GUI. We needed one. We didn't have one at the start. We literally just rendered the game on screen. There was no menu bar. There was no games list or anything like this. And it was a barrier to entry for users of the emulator. And so we sort of just thought, how's the quickest way we can slap one of these things together? It doesn't have to be the best. It doesn't have to be the final solution, but we just need something. And that's where GTK Sharp popped up out of, and it's worked. It's worked pretty fine until we've started to push its limits. Yeah.
And I think that's the point. Regardless of what people take away from any kind of learning that they do in software development, software engineering, computer programming, whatever you want to call the industry that we work in, it is bells and whistles last. Get it working first, because you don't know whether one of the things that I always say to junior developers when I work with them is the one thing you'll learn, and you should learn it very quickly, is that the person you're building the software for doesn't know what they want until you give them what they don't want. And you can extrapolate from that and say that, we don't know what we want for the user interface for Ryujinx or for this service we're building or for Netflix or for whatever you're building, right? We don't know what the user interface is going to look like, but we need to get something in front of the user so that they can use it and tell us, right, what you've produced is great, but can this button be over here? Because the majority of the times I build software, I'm not the greatest user interface designer ever, but I'll throw something together, like just slapdash, like push this button and it will give you bacon, or push this button and it will do the thing. Push this button for the TPS reports, right? Because it doesn't matter to me how that looks as long as you can discover the button and use the feature, because I'm building the feature. I'm not necessarily building the interface. And like you said there, right, you needed an interface. GTK Sharp may or may not be the best for this particular application, but it fit within that time period. Get it working, get it out to people, because for all you know, it may be that the code was running fantastically on your machine, because you may have a development machine with, like you say, a 15 gigahertz CPU with 48 cores and 12 gajillion bytes of RAM or whatever, right? And it works brilliantly on your dev machine. But until you get it into the hands of the actual users, you don't know whether what you've produced is actually useful, right?
And that's exactly right. When we started down the path of GTK Sharp, we didn't know what we knew today. And we can't have known until we attempted to do it. And so it's it's coming back to premature optimization, but not just in your code, but in your approach and your architecture. You can't optimize for things that you don't know about yet. And just getting nitty gritty, building, it doesn't have to be pretty. It can all just be code in one giant class for all I care, all shoved into one function. But so long as you have something working, there's always the ability to refactor, to update, to fix code later. You can spend, I struggle with this as a developer. I can spend endless time thinking about things and researching and documenting and stuff like that, to the point where I'll never write any code. It's just getting in there and getting started. That's 90% of the hurdle.
Yeah, I agree completely. Because and like we've sort of hinted at earlier on, if you separate the concerns of your application, regardless of whether it's an emulator, a game, a microservices architecture, a monolithic huge web app, whatever it is, as long as you segregate everything out and leave those, I've just finished reading Clean Agile and Clean Architecture by Uncle Bob. I'll leave the discussion of whether I agree with his politics or not to one side, but like the points he raises in those books are like, leave the technical decisions to the last possible minute, because you don't want to build your app so that it relies on those external libraries, right? Ryujinx may or may not, I don't know, I haven't had a chance to read the code properly yet, but it may not rely on GTK Sharp. And if it doesn't rely on that being there, just something that can accept some input and produces something on screen, then technically you can, like you say, you can swap it out for Avalonia, you can swap it out for Vulkan, you can swap it out for OpenGL. Heck, you can even, I mean, you wouldn't be cross-platform, but you could swap it out for DirectX, you know? Yeah. You could, you may end up going down a route where the system detects if Windows, then use DirectX, because DirectX is written for Windows. You know, you may go down the route of, we're on, I can never remember the one that Mac OS uses, but they've got their own, haven't they? It's kind of like Vulkan, but it's got like metal or something. Yeah. Yeah, right? So you could detect, hey, if Mac OS metal, you know, and you just say, I have an interface called iWindow, and I have the metal implementation, I have the GTK implementation, I have DirectX implementation. As long as you leave those decisions to the last and second, or segregate it correctly, separate those concerns out, it doesn't matter what user interface you use. And same with like database technologies, right? A lot of people, .NET, it's got to be EF Core. Okay, fair enough. But what about if you want to use Debonair or Dapper or, you know, any of these hundreds of other database technologies? Leave that decision to the last possible second. Yeah. And then build an interface. And it totally makes sense. And that's something that you could apply, like I said, game, emulator, business line application, whatever. Yeah, and that's one of my goals for Ryujinx in the end, is to treat it like a library where anyone can sort of add it from NuGet and add it to your thing, and then build whatever user interface you want on top of it. Ryujinx is a library. We bring the CPU emulator and the GPU emulator, but how you put it on the screen is completely up to you. And I think that leads very well into sort of the architecture of abstracting everything away, not relying on a specific technology. And we're not there yet, but it's definitely something that we're actively working towards, putting in place things like dependency injection and stuff like that. People might laugh at me thinking of adding dependency injection to something performance critical like a game emulator, but I think it's possible. And I definitely want to try it, and see if we can do it. And if we can't, well, then we've learned that we can't do it. Yeah, absolutely. Because then, you know, like you say, you've already sort of gone down that route of optimizing for performance. So we've got it performing quite well. Can we use dependency injection to swap a core component out at runtime? And does that affect it? And like you say, if you do that and it turns out that it does affect performance, you just go, well, undo. Yeah. Close pull request. Exactly, right? You're not committing yourself to it has to be this way. You have those options. And that, I think, is what real software engineering is all about. Is like, I have the option to swap this out. Whether I decide to or not, it doesn't matter. It means that 6 months' time, when we decide that this particular technology that we were using, it doesn't fit our use case anymore. And that's the important thing to say. It doesn't fit your use case anymore. It did fit previously, and some other technology may fit a little better, or it may fit completely. And it's having that option to be able to swap things out and change things around, I think is the most important thing. Like I say, regardless of whether it's a game, an emulator, a business line application, whatever it is, being able to swap things out is, I think, the most important thing.
Yeah, definitely.
So let's talk about the name just real quick, right? Because there was a really, really interesting tidbit that you dropped off air that I think is really quite interesting. So I know that you'd said earlier on Ryujinx, the part of the name comes from the fact that the Ryujit compiler exists, right? So just for a bit of background, the Ryujit is for those who don't know, is the just-in-time compiler that C#, F#, those kinds of things can use to just-in-time convert your C# ML, your intermediate language code. So let's take a step back, right? You write some C# code, you hit compile, out pops a DLL, which is compiled to the intermediary language, which is like the step in between native code and your code. And then when you run it, the JIT compiler comes in and says, right, this intermediary language, convert that to the operational codes for the CPU I am running on. At least that's my understanding of it.
Yep.
It's likely I'm greatly reducing the actual.
It's far more complicated than I'm sure, but that's
Absolutely.
the gist of it.
Yeah. And I happen to know that Ryujit, the name of the Microsoft JIT compiler that's used by .NET, is named Ryujit because Ryu is Japanese for dragon, and there is a very famous book in the computer science arena called the Red Dragon Book, which is a book on compilers, and on the front cover, it's a knight fighting a dragon. And so that's kind of where that comes from. But I'm interested to know, because you dropped this knowledge off air, just real quick, where the name for Ryujinx comes from.
Yeah, so the name Ryujinx, it comes from, well, Ryujin, which is a mythical sea god or a dragon, as you say. And the name stems sort of from the use of Ryu in the name Ryujit, which is the code name for the JIT that .NET Core uses. And then NX just so happens to be the code name, the internal code name Nintendo used for the Nintendo Switch. So all their game consoles, I don't know the internal code names for them all, but they all have an internal code name, and the one for the Switch is NX. And so it sort of sounds cool when you put it all together, Ryujinx, or Ryujinx as I call it. But that's where the name comes from, the sort of the combination of Ryujit and NX from Nintendo Switch. And I think it's fitting given that the initial implementation of the emulator happened to so heavily lend on Ryujit itself to do all the CPU emulation. I think it's quite fitting, and it's nice. It's a cool name, but it also has fundamental meaning behind it, and I think that's pretty cool.
I'm interested to find out, and you may not be able to answer this. It may be a question for GDK-chan. What came first, the implementation or the name, right? Because we all know that naming things is hard.
Yeah. I'm not sure. I'll have to ask.
Well, if you find out, we could do like a follow up or something. But yeah, that's a really interesting. Just name it. Like I said, naming things is hard, and it's just this wonderful sort of this cross pollination of the technology it uses and a whole bunch of stuff related to like what Nintendo calls the Nintendo Switch internally, and just bringing all of these things together. And like you say, you got a cool name out of it.
Yeah, that's all.
I can't do that with any of my projects, I'll tell you that much.
Yeah, I'm perpetually stuck in the, what do I call my project before I release it to the public?
Mm-hmm. Excellent. Okay, so you touched on the fact that Ryujinx and Yuzu sort of have evolved together. There's that intertwining of the teams working together, and like you said, competition is really important to breed innovation. Because if you aren't trying to catch up with the other team, the other people, you sort of get, I feel, you get kind of lazy and lax, and you go, you know what? It kind of works, and it's a little janky, and it runs at 24 frames a second.
But that's 24 frames per second than anyone else.
Exactly, right? But then if no one else is doing it, you end up with, well, that'll do. It's fine. And you kind of stop innovating. But if you have that competition, right, then it sort of helps. But do you know of any other open source projects that you or any of the other folks at Ryujinx have sort of used as inspiration. So, for instance, I happen to know that I, at one point, wanted to write a small operating system in .NET to see whether it was doable. And then, like, a week after I decided I'm going to do this, Scott Hanselman ported TinyOS to .NET Core. So I was like, well, I don't need to do that now.
Yeah. There's, in terms of direct inspiration for the project, not really. I mean, there's a lot of great emulators out there that we can draw sort of inspiration from, like RPCS3, which is a great open source PS3 emulator written in C, and it's they've even got a greater challenge than we do because the CPU in the PS3 is so arcane and so not normal. It's a miracle that they're even able to have an emulator for that console. So that's a really great one to sort of, they have a lot of problems that they've solved over time before that we've come along. I mean, the PS3 is like a 10, 12, I don't know how old console, probably even longer than that because the PS4 is probably that age. So 15-year-old console now. So they've had a long time to sort of sort out the same problems that we're trying to sort out. And so a few things like memory management tricks that we can pull on Windows, ways that we can use specific instruction sets on Intel and AMD CPUs to eke out extra performance. We're able to sort of garner that because RPCS3 is open source. There's also Cemu, which is another Nintendo emulator that's for the Wii U. It's not open source, it's closed source, but it's probably like, if you're after the best example of an emulator done right in terms of performance and features and stuff like that, Cemu is one of the great ones. So is Dolphin. But there's also a couple of other sort of C# emulators that are out there. Like there's CSPSP Emu that's available, which is sort of like a PSP emulator written in C#. And there's also JPCSP, which is also a PSP emulator written in Java. So it's not exactly C#, but it's very much the sort of the same problem. Java's a very similar language to C#. It's got the same sort of managed architecture. You sort of run into the same problems that you'd run into on C#. And so we didn't draw inspiration directly from those projects, but it's nice to know that there are other projects out there who are sort of trying to tackle the same problems that we are, and that there are other teams who are trying the same things that we are. And I mean, if we get stuck on certain things, there's always those teams that we can reach out to and chat to, and we hope that they can draw inspiration from us as well, that Ryujinx is a successful, I hope I can say, emulator done in C# and .NET, and I hope it serves as an inspiration for these projects going forward. That yes, you can write a PSP emulator in C#. Yes, you can write a PS3 emulator in C#. Do whatever you want. Here's an example of one that we've been able to, that one we've worked on and has worked out for us.
Sure, and I guess like I've been sort of saying a lot, it feels like it's a great implementation of all of those software engineering principles that we're told to use at work. Solid, that we're told to, well, it's essentially just solid, right? Do these things, right? And do them in this way because you will achieve great success. And I feel like a lot of the things that get built that are big applications end up trending away from those. And then they get to a point where, I mean, so for reference, we're recording this on 7th of January, right? And it's looking like it's going to go out in May, April time. So I can say this and not worry about it. I mean, look at Cyberpunk, right?
Yeah.
I have the feeling that they hadn't properly or weren't able to properly adopt things like continuous delivery and, unit testing or integration testing or any kind of testing, right? And so they had to just look, today is ship day, ship it, right?
It works on my machine.
Talked about exactly, right? And I've talked about this a couple of times on one of the other shows that I do, Waffling Taylors. Just the idea that you reduce scope or you reduce or you extend the time. And when you're in a business line application, you have to make those difficult decisions. But when you're making something as a hobby, you can go, you know what? Doesn't matter if it doesn't ship today. Doesn't matter if we have to take out this feature because it doesn't work, because we can look at it later and ship it as another feature. But I also think that the practices that you and the rest of the team might be doing would help other developers. And like you say, you're building something that is performance critical in the open for essentially for free. And that means that other developers like myself can come along and read through the code and go, oh, that's really cool. I really like what you've done there. Like you said earlier on, take this code, put it through the JIT, the .NET JIT, and get it exported so that it can run on my machine. That is a wonderful solution, albeit maybe not performance great, but a wonderful solution to an incredibly complex problem. And that solution provided for free by Microsoft.
Yeah. I think this leads good into sort of the discussion around .NET and its performance, if you will. .NET and other CLR languages aren't really known much for, well, not known much for their performance, but it's always like when you compare C# to C or C++, it's always like, oh, but C and C++ is better because it's lower level and it's faster. But I went into this with the same mindset, and I think it's proven to myself that actually, no, that's not the case. And I think that's one of the biggest surprise to me and myself is that, to myself and the rest of my team, is that it is possible to build these things. And we didn't know if it was possible because no one's done it before. But we hope this sort of sets up other teams and other developers who might also be interested in C# and also interested in consoles and emulators and stuff like that, that no, you don't have to go away and learn another language to do this sort of stuff. No, you don't have to not be involved in these projects because you don't have any experience in these languages. Try it. If you know Python, I challenge you to write a Nintendo Switch emulator in Python. Hey, it may not be possible, but who knows? I didn't think it was possible to do in C# before I did this. And I think that's a great lesson to take away, even not only for myself, but for other people, is that just try it. The worst case scenario is it doesn't work. No harm, no foul, really.
Exactly right. And if it's in Git and it doesn't work, you can either just ditch the repository or you could leave it there and say, hey, if anybody knows how to fix this, go ahead and try it, right? Because if it's open source, anyone could jump in and go, right, I see what you were trying to do. I think I have a solution. Here you go, right? And you can learn from that. Even the most experienced developers. Like, I feel like you and I have the same number of years of experience, and I would never have known where to start to build an emulator for a new, I haven't even built an emulator for an old system, right? Emulating an entire CPU architecture, regardless of whether it's a real commercial product or something that isn't real, like the Chip 8, like the Donald Knuth machine, or like you say, the RPCS3, just like taking the PS3 CPU, which does not match anything else.
Heck, it doesn't even have any public documentation. So I have no idea how they managed that. We're lucky that ARM is a well-known architecture. We can just go to ARM's website and download the technical reference manual, and it's 10,000 pages long, but we can garner all the information that we need from that. But RPCS3 is built on a CPU architecture that basically has no public documentation. That's genius to me. Like, I don't know how they did that. I wouldn't know how to approach that.
Yep. But like you say, you don't know until you try, right? So, and until you try and look into how do I figure out how a CPU architecture that is closed, that doesn't have any public documentation, how do I figure that out? How do I work out how it works? Well, it could just be that you get a CPU, what do they call them? The clamps you can put on a CPU and read all of the pinouts. But then you need to find someone who ships one of those for the PS3 CPU. Or maybe you just put a bunch of probes on there and just read what's happening. Or maybe you go down and I'm not advocating this, but you go down the route of, let's talk to someone at Sony or talk to someone who has fallen out with Sony. Can you tell me a little bit about it? Or nobody knows, right? I'm not trying to advocate any of those steps, because I'm sure every single one of those is illegal in some way. But, you don't know how to get to the solution of the problem until you try, right? If somebody would have told, like, the very first time anyone does FizzBuzz, right? The very first time anyone does FizzBuzz, they have no idea. I taught my brother how to do FizzBuzz on paper. And he was like, oh, that's really clever. Like, the mod, because I taught him modulo operations, the divide and check the remainder. We did it on paper. I then taught him how to do it in Python, and I don't even know Python. I didn't know it was possible to do it in Python. It's the same operator, and it's the same setup. But like, until you try, you never know whether it's possible.
Yeah, for sure.
And I think that's one of the cool things to take away. Hopefully, there's loads of stuff to take away from this conversation, but the one of the cool things to take away from this conversation is that until you try to work on a solution, there's no way of knowing how you get to the end of that solution. I think that's an important thing for developers to always be curious and always be looking and trying to figure out, how do I do this? Right? Because, right up until the DevOps and microservices, I'm trying to go for all the buzzword bingo. I don't know whether you can tell, but until DevOps and microservices became huge in the early, I want to say the mid 2000s, nobody ever would have thought of doing that and how they would do it. And then, microservices happened, and DevOps, continuously delivering, push completely out to live constantly, is something that some companies are happy with and some companies are not. And until we got to that part, we didn't know whether a company would be happy with it. There were parts of the Microsoft tool chain that they push to live several times a minute because they want the latest code out there. There are parts that they don't. .NET is one of those where they don't want to push out a brand new installer every time someone adds a new semicolon or something because it might break. But they put out a nightly build for it, right? So you can try it out. Netflix is imminently famous for we're always pushing to live, to production. But what they don't tell you is that's about 10% of their business that they push to production because they don't want the rest of it to break.
Yeah. I mean, Netflix is an excellent example. I encourage any developer who is interested in this sort of stuff to go and read Netflix's tech blog because it is absolutely amazing, the stuff that you can take away from what they're doing. But yeah, Netflix's architecture is really interesting with the way that they use microservices and they're continuously testing and stuff like that. And it's nice to be able to read the examples of these people who solve these problems day in and day out. And that's what I hope Ryujinx is to the next guy who's going to write an emulator, is that here's an example of what to do. May not be right, may not be wrong, but here's an example. Here's what we've done. Here's us documenting it. And that's one of the great things about open source code. And I'm so glad that it is an open source project, is that the entire evolution of the project is forever, hopefully, encased in the Git repository. You can go back to the very first comment that was ever made, and you can see why every piece of code was done. And hopefully we've documented our pull requests well enough that you can understand why we did that performance sensitive thing and why we sacrificed code readability in this area for extracting extra performance. And I guess our code is our documentation. It's our tech blog sort of approach to the things, is that you want a good example of how to do, well, I'll try to be humble here. I'm not claiming it's good, but you want an example at least of how to do this sort of thing. Go check out the code, have a read through it. As you say, the easiest way to learn something is just, or in my mind, the easiest way to learn something is just to read the code.
Yeah. I mean, you could write maybe a 3,000 blog post article on why we did this one function this way, or you can read the code and run it and go, oh, I get it now. Yeah, they've done it that way because it reduces CPU intensity, or, they've used the no zeroing, I've forgotten the name of the attribute now, but the no zero attribute, because in this method, it needs it to not be zeroed because they're using the variables and all that kind of stuff immediately, and those values will be overwritten. The garbage values will be overwritten. So we don't need to waste time, zero everything out before we hit that method. Totally makes sense to me. And you can get that from reading the source code. You could get that from reading a 4 or 5 page article, or you can just read the method and go, oh, I get it now. Totally. Excellent. Okay, so where we talked a lot about Ryujinx. I'm trying to make up a whole bunch of different ways to pronounce it, just to really upset all of the developers. Not really, just make it fun.
Oh, I'm sure you've hit the nail on the head for how we all pronounce it so far. So
excellent. As long as I've done it once, what I can do is I can copy paste that out and put it throughout the conversation.
Yeah, if you could do that for me as well, that'd be great.
Excellent. But I'll do it with my pronunciation of it, so that it'll be like your accent with me saying it. Because that'll be fun, right?
That'd be interesting.
Yeah. But yeah, so how do people find out about like, where's the best places to go? You've mentioned that it's on Git. You've mentioned that, you can go get the code and you can go download it and you can go run through it. But like, where can I find these things? Do I just literally hit Google and attempt to spell it out how I've pronounced it? Like, what's the best places to go?
Yeah, so our website has links to pretty much all of our things. I'm not going to pretend to spell it out for you, but if you can somehow manage to get to our website, ryujinx.org, all of our developers hang out on Discord. We have a Discord server for the emulator, and we're all pretty much on there fairly actively. So if you're looking to get involved, you're looking to contribute, you're just looking to support us via Patreon or just by hanging out and using our emulator and spreading the word, hit us up on Discord. We're all there. We're all friendly. We're more than happy to step new developers through who are interested in C# and .NET, showing them how they can get involved. We have on our GitHub, it's linked from our website as well. We have a bunch of issues tagged as good first issue. So if you're looking for an easy one to tackle to get into the project really and figure out how stuff works, go check out that list. And then you can contact me, JD. I'm in the Discord, or you can contact any of our developers who are online with the developer role, and we'll give you a hand.
Awesome. Okay. Well, maybe we'll get more people submitting code, or even just finding it and using it and being able to say, hey, my weird system, which uses a CPU from 12 years ago and 18 bajillion gigabytes of RAM and is held together with gaffer tape and spit, doesn't run this system. How do I make it run? And you can go buy a new computer.
Yeah. That's pretty much the answer you get from us. There's only so much C# can do. Okay.
Yeah, absolutely. Even if you are still using the JIT.
Yeah.
Excellent. Well, I mean, all that really remains to say is thank you ever so much for being on the show, JD. I really appreciate it, especially since it's early afternoon for me, which means it must be like 2:00 in the morning for you, right?
Almost. It's getting there.
Oh my goodness. Well, time zones are hard. And I want to thank you ever so much for taking the time. And I know we've tried to do this a few times and it's kind of fallen over because of time zones, because time zones are hard.
Yes, for sure. Definitely. I'm still not quite sure what time zone you're in, but we managed to make it work.
Well, yeah, I mean, I'm in the UK, so it's GMT, which I think is UTC, but I don't know. Too many acronyms. I don't know.
We made it work.
But hey, it worked, right? Excellent. Well, thank you ever so much, JD, for being on the show. And thanks to the entire team at Ryujinx, because otherwise this whole episode would never have happened. Because I kind of approached, I think I reached out directly to GDK Chan. I went, can I please talk to someone on the podcast about this? And just obviously a conversation happened. Yeah. We've gotten here now. So yeah, thank you ever so much.
No worries. And I just have to add, this project is in no way mine. I'm compared to the amount of code that GDK Chan and everyone else on our team has written for this, I'm a very small blob. So I just have to say, massive kudos to everyone on our team and every contributor to this project who's managed to make it what it is today. I'm just one of many, and I think what we've been able to pull together is pretty amazing, and I'm just glad to be part of the team.
It's an amazing team, I have to say. I have talked to a few people on the Discord, and I was like, hey, can you answer this? And straight away, hey, look, go check this out, or go read this, or check this bit of code, or this is how it works. Just amazing bunch of people from my point of view, and imminently approachable. It's absolutely wonderful. But brilliant, yeah. So thanks for being with us, JD. And
no worries.
Yeah, we'll hopefully maybe be able to catch up again when you've implemented the next version of whatever's happening. Maybe
when we've emulated the next console that Nintendo brings out.
That's it, right? Maybe in the .NET 6 timeframe, .NET 7, we can maybe come back and say, hey, what were some of the best things about? What have you been able to adopt now? Because you hinted at earlier on, there's a few things in .NET 6 which are going to make things a little easier for you, but we'll leave that for another time, perhaps. I don't know.
For sure, definitely.
Excellent. Well, thank you ever so much, JD.
Thank you very much.
There was my interview with JD of the Ryujinx team. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice. Head over to .netcore.show/subscribe for ways to do that. And to come back next time for more .NET goodness. See you again real soon. See you later, folks. The .NET Core podcast is a production of RJJ Software Limited.